Okay, students, for the second part of our study of significant figures, we've already established the number of sigfigs that each of these example problems have in them. What we want to do now is to learn how to take values that we come up with in a calculator and round them to the correct number of sigfigs. Now, what do I mean by the correct number of sigfigs? We'll talk more in the next few days about the fact that when we make calculations, we must make sure that the answer that we get has no more sig figs in it than the values we use to calculate it with. We can't have a really exact answer based on some really general measurement values. So we can't calculate with inexact values and get a really exact number. So we have to be able to round our answers to a specific number of sig figs. And again, we'll learn more about that part in the next few days. Today what we want to do is to look at these example values we have and to determine how to round those to a specific number of sig figs. Now let's start with rounding to 3 sig figs. When we round something to a number of sig figs, the first thing we want to do is to mark all of our sig figs. Now we did that earlier. We said that all of these were significant, that these 3 were significant, that only the last one was significant in this one. All 3 of these, only the first 2, and then every one of these were significant. The first thing I always ask that you do is to, and I'm going to make you do it on your worksheet, so make sure you do this or you're going to lose points. I want you to draw a line in that number value at the point where you've reached the target number of sig figs. Okay, what did I mean by that? If I want to have 3 sig figs in my answer, then I'm going to go to this first value and I'm going to draw a line here after 3 sig figs. And then what I want to do is take those 3 sig figs and look at only the very next value, because what I want to decide is if I'm going to be able to keep the value up to that line and just drop the rest, or if I'm going to need to round up, and also if I'm going to need to replace some digits with zeros. I can't leave whole number place values blank. You'll see what I mean by that in just a minute. But for right now, the number right after the red line is a 0. 0 to 4, we can just drop. And if it's not a whole number, if it's after the decimal, we don't have to worry about it. We just drop it and only write the digits that come before that red line. Since this number is a 0, I can just drop it. Since it comes after the decimal, it's not a whole number of digits, so I don't have to replace it with anything. Rounding this to 3 sig figs is simply 1.02. In the next value, if I draw my line after 3 sig figs, I'm going to draw my line here. Now this one's easy. Since it only had 3 sig figs in it in the first place, I don't have to worry about rounding, replacing with anything. I just simply write down 45.0. Now this next one shows us a little bit of glitch. Now look what happened here. We've only got 1 sig fig in this problem, and we need 3 sig figs in the answer. We have to have the correct number of sig figs. But if you think about it, since this is a decimal value, if we put zeros at the end of this number, does it matter how many zeros we put after this number? Does it change the number value any? Well, no, it doesn't. So once I put those zeros on the end, think about what that does to the significant figures. If I put those zeros on the end, they're ending zeros now, and remember, ending zeros are significant if there's a decimal showing. And since there's a decimal showing, any zeros I put on the end are going to be significant. Since that's true, I can now use those extra zeros I put in and count out my 3 sig figs. There's my 3 sig fig line. And since the number after the red line is an understood 0, I don't have to do anything since it is not a whole number 0. It's a decimal 0. I don't have to replace it with anything. I can simply write my number value 0.00003 and tack those two zeros on the end, and I now have my 3 sig fig rounded value. The next number is also easy since it only has 3 sig figs in it. I don't have to worry about rounding, dropping, anything else. I can just write down the 154. The next value gives us a new and different problem, and I have a feeling most of you have not heard of what we're going to do in order to solve this situation. If you look at this problem, there's only 2 sig figs in it. If we put a decimal at the end, I have lots of people give me ideas of things to do to make this work out to 3 sig figs. If I put a decimal at the end, what's that going to do? Well, now there's a decimal showing, so what did it do to every one of those zeros? Made them significant, so now we've got 8 sig figs. That won't work. They say, okay, put 0.0. Well, that didn't help anything because we just added yet another sig fig because now we have a decimal showing and 7 ending zeros. So neither one of those are going to help us any. So how are we going to get an extra sig fig? Well, there's a little known rule in science that says, and I'm going to put this up here at the top, if you have a 0 with a bar over it, now this has to be a decimal 0, not for one that's at the begin, a whole number 0. It doesn't work for ones that are after a decimal. But if you have a whole number in a position, a place value that's in a whole number position for a 0, and that sounded kind of garbled, but it will have, if with that bar over the 0, it will make that 0 significant. So all I need to do to turn a 0 into a sig fig is to put a bar over it. Now again, it won't work for something like this. You can't put a 0 over a decimal 0. Those won't work. Neither one of those would you ever see. Okay? But for this one, if I put a bar over one of these zeros in this number, let's say I put a bar over that 0, it would make it significant. But we have to be careful which one we put it over. Because think about it. If I make this 0 at the end significant by putting a bar over it, what did I just do to all those zeros in between? Well, since they're now surrounded by a sig fig, I just trapped them all. So I turned all of those zeros into sig figs. So I can't put the bar over the 0 there. Where would be the logical place to put the bar? Right here. If I put the bar over this 0, it turned this one into a sig fig. Now I can draw my line. Whoa. Not only was it a bad line, it was the wrong color. I can draw my line here. The next number is a 0. I don't have to change or round up or anything. I can simply write my 5, 4, 0 with a bar on it, and then simply write the rest of the zeros down. I can't drop them. They're whole number. They're in whole number positions. So I can't drop those whole number place values. So 54 million with a bar over that first 0 is going to have 3 sig figs. So see if you can do the last one yourself real quick. Round that one to 3 sig figs. Hopefully you realize that if you don't drop this decimal, you're never going to be able to turn it into 3 sig figs. So if you drop that decimal, you turn all of these into non-significant zeros. So if those are no longer significant, we can solve this problem the same way we did the one just before, and by simply putting a bar over that 0, we can change that into 3 sig figs. So that's rounding to 3 sig figs for each of those values. So what about rounding to 1 sig fig? Try it first of all, just see how you do by turning or by pausing the video and see if you can figure out how to get these to 1 sig fig, thinking about the rules that we've used so far. So hopefully you gave it that attempt, because anytime that you manipulate data yourself and try to figure things out yourself without having to be told first will really improve how long you retain the information. But hopefully you went through after each one of these and you marked your sig figs again. I want to see those sig figs marked. And that you did the same thing we did before. You drew a line after one sig fig. So in all these cases, we're drawing a line after one sig fig. Now remember, we're always going to look at the number directly after that sig fig. So in this first case, we're looking at the 0 here. In the next case, we're going to be looking at that 5. There's nothing after this one, so that one's going to be easy. In this case, we're looking at that 5, the 4 here, and the 7 here. You're only looking at the very next number. So in this first case, since the very next number is a 0, and since we're not trying to drop any whole number place values, then rounding this to one sig fig is easy. It's just 1. The next one, people will get caught on this one over and over and over again, because yes, the next number is a 5, and anything from a 5 up, 5, 6, 7, 8, or 9, we've got to round up. So since this value is a 5, we're going to need to round that 4 up to a 5. And I get tons and tons and tons of people tell me that when you round to 45, you round to one sig fig, it becomes 5. Well, if that's true, I want to owe you money, because if I come up to you and I owe you $45 and I say, well, I'm going to be nice and round up, I'm going to round that to 5. So I'm going to give you $5. Well, yeah, 45 does not round to 5. You dropped a place value. When you round up, all of those place values up to the decimal must be replaced with zeros. So since we're supposed to be dropping that 5, and it's in a place value that's a whole number place value, we have to replace it with a 0. So rounding that up to the 5, we have to replace that with a 0. And remember, since there's no decimal showing, is that 0 significant? No, it's not. So it's an ending 0, not significant unless there's a decimal showing. So we have our one sig fig with 50. The next one's easy. We only had one sig fig in the first place, so all we have to do is simply write down that value, 0.00003. In the next one, see if you can do the next one. If you haven't already tried it, now that we've gone through a couple of these, see if you can do this one. And if you've already tried it, hopefully you realize, since we're looking at the very next digit after our red line, which is a 5, that 5 tells me I've got to round that 1 up to a 2. So I write down a 2 here, which is all fine and good, but think about it. Did I drop whole number values? Make it logical. Can I round 154 to 2? If you said yes, then again, I want to owe you money. But hopefully you realize that if I drop those place values, those whole number place values, everything up to that understood green decimal I just put in here has got to be replaced with zeros. So I'm going to replace the 5 and the 4 with zeros, and 200 only has one sig fig. The next one, since the target value is, or that number that we're going to be looking at after the red line is a 4, we do not have to round up. Therefore, we can just drop it. Now, when we drop it, I hope you for sure know that you cannot round 54 million to 5. 54 million can be rounded to 50 million, because when we drop that 4, we must replace with all of those whole number place values with zeros. And finally, the last one, since the digit that we're looking at after our sig fig line is a 7, that means we're going to have to round up, and 9 rounds up to 10. So we're going to round that to 10. Remembering that we must replace all of the rest of the whole number place values with 0. So I'm going to replace that 7 with a 0, and all of the rest of those zeros must remain. And somehow I managed to lose a 0. Let me try that value again. It's going to end up being instead of 97 million, 100 million.